Okay, so we're about to dive into this really cool story where old tech meets new tech. We're talking about teaching AI, artificial intelligence, how to read something from, a world of spinning needles and printed numbers. So think about this for a second. What's the one thing that connects a power plant from the 70s, a super modern factory, and even the water meter on the side of your house? It's a piece of tech that's been around forever, and you probably see it all the time without even thinking about it. Yep, it's the good old analog gauge. I mean, these dials are literally everywhere. Even though we live in this super digital age, they're still out there, silently and tirelessly monitoring our world. They're this direct link from the past right into our present. And this is where things get really interesting, because the sheer number of these gauges, well, it creates a huge problem, but also a pretty massive opportunity. And look, we're not talking about a handful of old relics sitting in a museum. We're talking about millions of these things, active right now, tracking really critical data, pressure, temperature, you name it. In a way, they were the original data dashboards. And the thing is, they still work perfectly. So that leaves us with a big problem, right? What do you do? Do you just rip out all of this equipment that's working just fine and replace it with something digital? I mean, the cost of that, both financially and environmentally, would be astronomical. Or, and this is the key, is there a smarter way to do this? A way to bring this old school hardware into the 21st century?
Which, leads to the obvious question. We've all got these amazing cameras in our pockets. Why can't we just point a camera at the gauge and have an app read it? It sounds so simple, but as it turns out, for a computer, this is an incredibly difficult problem to solve.
Okay, so why is this so hard? Why is reading a simple dial so tricky for an AI? Well, it all comes down to one thing. The real world is messy, and a computer has to deal with all of that mess.
I mean, the problems come from everywhere. For starters, the camera is almost never looking at it dead on. Then you've got glare, you've got weird reflections, shadows, not to mention that there are endless different types of gauges, different fonts, different colors, different needles. It's a mess.
Let's just hone in on that first problem for a second, the camera angle, because it's a biggie. It's called parallax error. You've actually seen this before. It's why your car's speedometer looks like it's pointing to a different speed depending on whether you're the driver or the passenger. That little gap between the needle and the dial, it changes the reading based on your angle. For an AI trying to get an exact number, that's a total disaster.
So to get around all this, a team of researchers came up with this really elegant solution. It just cuts right through all that complexity with a surprisingly simple three-step process. All right, here's how it works. Step 1, the AI looks at the image and just finds the gauge. Simple enough. Step 2, and this is where the magic happens, it warps the image to correct for that weird camera angle. It basically turns that distorted view into a perfect, head-on shot. And then, only after it has that perfect view, does it go to step 3. It reads the value. So it's detect, correct, and then read. Super simple. And that correct step, that's the whole key. It totally gets rid of that parallax error problem we were just talking about. By creating this, perfect image to look at, the AI can get an incredibly precise reading, and it doesn't matter what angle the camera was at. Okay, but wait, this brings up an even bigger question, right? To teach an AI to be this good, you'd need, what? Millions of photos of every single gauge out there, taken from every possible angle in every kind of lighting? I mean, collecting that much real-world data is just impossible. So how on earth did they pull it off? Well, here's the brilliant part. They didn't. They realized they didn't need any real photos. Not a single one. The entire system was trained on 100% fake computer-generated data. And we're not talking about a few dozen examples here. They created a massive library. Get this, they generated 10,000 unique synthetic images to train this thing. Yeah, they basically used 3D software, the same kind of stuff they use to make video games and special effects in movies, and they just built a virtual world of gauges. So the AI that is now so good at reading real-world gauges has literally never seen a real one before. Its entire education came from this fake synthetic dataset. And to make sure it was ready for the real world, they randomized everything. I'm talking over 50 different variables for every single image. They changed the lighting, the reflections, the shape of the needle, the fonts on the dial, you name it. It's kind of like chaos engineering for AI. It forced the system to learn the idea of a gauge, not just memorize a bunch of pictures. So, okay, the idea is brilliant, but does it actually work? Well, the results are, honestly, they're pretty staggering. This isn't some slow process that happens on a supercomputer later.
The system is so efficient that it can run in real time. We're talking 25 frames per second on a regular smartphone. That's live analysis right there in your hand.
And when you put it up against the old ways of doing this, it's not even a contest. The previous best method was super unreliable. It often just failed completely. This new system, though, it's not just way more accurate, it's also incredibly reliable. It gets a successful reading pretty much 100% of the time.
So what this all means is that these researchers have really cracked the code. They've built a bridge, a seamless connection between the old school, mechanical world and our modern digital one.
And that's why this is such a big deal. All of a sudden, a piece of equipment that's 50 years old can be a part of the Internet of Things. You can monitor it remotely, log all its data, run automated checks on machinery that was built way before the Internet was even a thing. And you don't have to replace a single bolt. Which kind of leaves us with one last really cool thought to chew on. If AI can learn to read these old things, what else can it read? What other obsolete tech is just sitting out there, waiting for a pair of digital eyes to bring it back to life?